Principal. Principal is the original sum that has been invested or lent or borrowed. For example, if one borrows, loans, or invests $100,000, the principal amount is $100,000. Interest. The word interest is the price paid for borrowing money and is expressed as a percentage rate over a period of time. Per annum. Per annum is Latin for each year. Capital. Capital is the assets or money owned by an individual who has accumulated wealth. These assets can be used as capital for borrowing and lending money from banks.
Simple interest. Simple interest is money that is paid only on the original capital, but not on interest arising from that capital.
Appreciation. An increase in cost or value is known as appreciation. Loans and investments are some things that appreciate in finance. Land, housing, collectibles, salaries, and the cost of food also appreciate over time.
Inflation rate. The rate of increase in prices within the economy over a period of time is known as inflation rate.
Flat rate. A flat rate is a rate of taxation that is not progressive, but remains at the same proportion on all amounts.
Compound interest. Compound interest is based on the idea of simple interest. However, it is designed to make the amount of interest grow larger through the increase of principal, the original sum that has been invested, lent, or borrowed.
Growth. Exponential growth is characterized by an increase in growth with each successive time period.
Decay. Exponential decay is characterized by something decreasing by a smaller amount with each successive time period.
Compound interest. Compound interest is interest that accumulates on the initial principal. Compound interest is based on the idea of simple interest, but is designed to make the amount of interest grow larger and larger by increasing the principal. Compounding of interest allows a principal amount to grow at a faster rate than simple interest, which is calculated as a percentage of only the principal amount.
Consider this situation where $1,000 is invested for 4 years at 6% per annum. The initial principal of the first year is $1,000. Now to find the interest, we must use the formula principal times rate times time, and this gives us $60. $60 is then added to the principal, which makes a total of $1,060. Instead of simple interest where you would use the same principal, we then use the total of the first year, which is $1,060 as the next principal. So using the formula again with $1,060, we get an interest of $63.60, and this gives us a total of $1,123.60. Using this pattern for the next 2 years, we get a total of $1,262.47 at the end of the 4 years.
Compound interest is also calculated in the following formulae. Calculating compound interest annually. For this, we use the following formula. A equals P in brackets 1 plus R to the power of N, where A equals the amount of the loan or investment after N years, including interest, P equals the principal, R is the rate of interest per annum as a decimal, and N is time in years.
Calculating compound interest more than annually, we use the following formula. A equals P bracket 1 add R over N bracket to the power of NY, where A equals the amount of loan or investment after Y years, including interest, P is the principal, R is the rate of interest per annum as a decimal, N is the number of times the amount is paid annually, and Y is the time in years.
For annual payments, consider a situation in which $12,500 is compounded annually for 7 years at an interest rate of 15% per annum. So in this case, we are trying to find the amount loaned or invested after n years using the annual compounding formula. So P, or the principal, is 12,500, R, or the rate, is 15%, or as a decimal, 0.15, N is 7. So A equals 12,500 in brackets 1 plus 0.15 to the power of 7. This equals 12,500 times 1.15 to the power of 7, and this equates to $33,250.25.
For frequent payments more than once per year, consider a situation in which $100 is compounded quarterly for 1 year at an interest rate of 15% per annum. In this situation, we're trying to find the amount loaned or invested after Y years. So we use the formula, which has been explained before, where the interest is compounded more than once a year. In this situation, P is 100, the rate is 15%, so it's written as 0.15. N is 4 because it's compounded quarterly, 4 times a year. And Y is 1. So substituting them into the equation, we have 100, bracket 1 add 0.15 over 4, bracket to the power of 4 times 1, which is a total of $115.87.
How is compound interest different from simple interest? The difference between compound interest and simple interest is that simple interest is calculated as a percentage only on the original principal or the original amount of money loaned, whereas compound interest is calculated on the original principal of a loan in the first year, and then by the original principal as well as the first year's interest in the second year. This continuous addition of interest each year to the principal is known as compounding, hence the name compound interest.
This table explains the difference between simple and compound interest. As you see, the initial principal in both situations is the same. And when the interest is added, they have the same amount in total. But the difference between simple and compound is the principal stays the same in the simple interest, whilst the compound interest then uses the total amount of the first situation as the next principal. This pattern is followed for the next year, and so on.
For annual payments, consider a situation in which $40,000 is compounded for 1 year at an interest rate of 8% per annum. So in this instance, we are trying to find the amount loaned or invested after n years using the annual compounding formula. So P, the principal, is 40,000, R, or the rate, is 8% or 0.08, and N is 1. So when substituting these values into the formula, we have 40,000 in brackets 1 plus 0.08 to the power of 1, which equates to $43,200. Consider a situation in which $20,000 is compounded for 4 years at an interest rate of 12% per annum. Therefore, in this instance, we are trying to find the amount loaned or invested after n years using the annual compounding formula. So, we have P, which is 20,000, R, or the rate, which is 12%, or as a decimal 0.12, N, the amount of years, 4 years. So, when we substitute these values into the formula, we have 20,000 in brackets 1 plus 0.12 to the power of 4, and this totals to $31,470.39. For frequent payments more than once per year, consider a situation in which $30,000 is compounded quarterly for 8 years at an interest rate of 9% per annum. So in this instance, we're trying to find the amount loaned or invested after Y years using the compounding formula for payments more than once per year. So we have the principal, which is 30,000, the rate, which is 9%, or as a decimal, 0.09, n, the amount of times the interest is compounded per year, is 4, and y is 8. So when we substitute these values into the formula, we have 30,000 bracket 1 add 0.09 over 4 bracket to the power of 4 times 8, and this totals to $61,143.09.
Consider a situation in which $16,000 is compounded monthly for 2 years at an interest rate of 12% per annum. In this situation, we're trying to find the amount invested or loaned after Y years, using the formula for compound interest when it is compounded more than once a year. In this situation, the principal is 16,000, the rate is 12% or 0.12, n is 12 because the interest is compounded 12 times per year, and y is 2. So when we substitute these values in, we have a equals 16,000 bracket 1 add 0.12 over 12 bracket 12 times 2, and that gives us a total of $20,315.75.
Consider a situation in which $500,000 is compounded weekly for 5 years and 9 months at an interest rate of 17% per annum. So in this case, we want to find the amount loaned or invested after Y years using the compounding formula for frequent payments more than once per year. So in this case, we have P, which is 500,000, R, which is 17%, or as a decimal, 0.17, and N, the amount of times per year the interest is compounded, is 52 weeks per year, and Y, which equals 5.75, the 0.75 being the 9 months. Therefore, when these values are substituted into the formula, we have 500,000 in brackets 1 plus 0.17 over 52 to the power of 52 times 5.75, and this equates to $1,326,784.64.